Hello everyone. So today we will be dealing with a new topic, that is heterocyclic compounds. Now what do you mean by heterocycles? So heterocycles are compounds having one or more heteroatoms along with carbon. So any compounds that have one or more heteroatoms. Now these heteroatoms can be either nitrogen, oxygen, sulfur, phosphorus, boron, various n number of heteroatoms are present. So heterocyclic compounds are the compounds having one or more heteroatoms, that is boron, sulfur, nitrogen, oxygen, phosphorus, etc. along with the carbon are known as heterocyclic compounds. For example, you can see here this is a heterocyclic compound because it contains carbon along with the oxygen. So this compound is known as furan. This compound is furan as it is a it is a heterocyclic compound because it contains carbon along with the heteroatom. Similarly, this is also a heteroatom, either one heteroatom or more than one. Here you can see in this there is only one heteroatom, but in this example there are two heteroatoms, and this is known as imidazole. So this moiety is known as imidazole because two nitrogen atoms along with carbon are present in a 5-membered unsaturated ring. Here also 5-membered unsaturated, but only one heteroatom is present. So this is regarding heterocyclic compounds. So these heterocycles are classified into two different classes. One is aliphatic or non-aromatic heterocycles, and the second classification is aromatic heterocycles. Now what are aliphatic or non-aromatic? Aliphatic, as you know, these do not contain any unsaturated bonds. These do not contain any unsaturated bonds. They are completely saturated, and such saturated system must contain heteroatoms along with the carbon. Such system is known as aliphatic or non-aromatic heterocyclic compounds. Let us see an example. So as we know, it must contain only saturated bonds. So this is saturated bond, and it must contain also heteroatom. So you can see here two heteroatoms along with carbon saturated bonds. So this is known as 1,4-dioxane. So the common name of this compound is 1,4-dioxane. Also, you can see a saturated ring system along with the heteroatom. So this compound is known as aziridine. So these heterocyclic compounds, either they may be 3-membered, 4-membered, 5-membered, 6-membered, or they may be also bicyclic in nature. Means two cycles are being fused together to form a heterocyclic compound. So what are aromatic heterocycles? So as you know, aromatic compounds, these are unsaturated. These contain unsaturated bonds, while the aliphatic compound contains saturated bonds. So these aromatic compounds that are unsaturated in nature and contain heteroatom along with the carbon are known as aromatic heterocyclic compounds. So let us see an example. Again, these can also be 4, 5, 6 and fused heterocycles. So let us see. So here you can see a 5-membered ring system, unsaturated along with the heteroatom. So here heteroatom is sulfur, and this compound is known as thiophene. This is 5-membered unsaturated along with the heteroatom. This is known as thiophene. Let us see example for 6-membered unsaturated heterocycle. You can see this is 6-membered ring, unsaturated, and oxygen is a heteroatom, and this is known as pyran. Also if it contains two heteroatoms, nitrogen, nitrogen. Here you can see 6-membered with unsaturated bonds along with two heteroatoms. This is known as pyrimidine. This is known as pyrimidine. Also fused heterocycles. Example is you can see here one ring is benzene while the other ring is furan. So this is known as benzofuran. As you have all seen furan structure, similarly furan and benzene. So this is known as benzofuran. So this is how the heterocycles are classified into aliphatic, that is saturated heterocycles, and aromatic, that is unsaturated heterocycles. So now let us see how this nomenclature is being assigned to the heterocyclic compounds. We see that there are different sizes of rings in the heterocycles. So if the ring size is 3, 4, 5 and 6. So to indicate that the heterocycle contains 3 sized ring, then in the nomenclature IR must be included. If it contains the ring size that is 4, ET, if it is 5, OL, and if it is 6, it should be IN. This is known as stem. This stem indicates, that is these wordings indicate the number of ring atoms present in the, or number of ring size present in the heterocyclic compound. Now suffixes. There must be a suffix also present in the heterocycles. So these suffixes are related only to the unsaturated compounds, that is aromatic heterocycles. So if ring size is 3, the suffix must be irene. This is only possible if the ring containing nitrogen atom is present. If in a ring, if we consider there is a 3-membered ring containing nitrogen and it is unsaturated, then only such compounds suffix is given as irene. If it contains 4-membered ring, the suffix must be ete. If it contains 5-membered ring, the suffix is ol. If it contains 6-membered ring, the suffix is ine. Similarly, if it does not contain nitrogen, that is the nitrogen, if it contains any other heteroatoms. It is just for an example that if it contains any other heteroatom like oxygen or sulfur, it might contain oxygen, sulfur, phosphorus or boron. That is, the heteroatoms must be other than nitrogen. If such case, then 3-membered ring will be suffixed as irene, 4-membered ring et, 5-membered ring ol. There is no difference in 5-membered ring, that is for nitrogen containing as well as nitrogen without containing nitrogen ring, suffix will remain same, while nitrogen containing without nitrogen containing suffix for the 6-membered ring will be in. Here it is in, while it is in. This is the first rule of nomenclature, that is how to indicate or identify the number of rings present and how to identify which heterocyclic compound is present. Either it is the ring whether it contains nitrogen or it is a ring that does not contain nitrogen, but it is specifically only for unsaturated, that is aromatic heterocycles, not for aliphatic heterocycles. The second rule is it must contain some prefix also. So these prefixes are based on the nature of heteroatom present. Example, if oxygen is present, so prefix given is oxa, oxygen, oxa. If nitrogen is present, it is given as aza, oxa, aza. If sulfur is present, then prefix given is thia or thio. So prefixes, if oxygen is present, it is given as oxa. If nitrogen is present, it is given as aza. If sulfur is present, then it is given as thia or thio. You can see your example. If it contains 3-membered oxygen, so this will be oxyrane, because oxygen suffix must be oxa or oxy. So it is oxyrene. So if it contains nitrogen as an heteroatom, let us consider a fused heterocycle. Fused heterocycle is nothing but containing more than one ring system is known as fused heterocycle. So you can see there is a nitrogen. So this compound is commonly known as carbazole, azo or aza. Next, sulfur. For this example is thiophene. Sulfur, thia, nitrogen, aza, oxygen, oxy or oxa. Now the third rule is if it contains more than one heteroatom. If a heterocyclic compound contains more than one heteroatom, then the then the heteroatom having high atomic weight. Heteroatom having high atomic weight gets preference in the naming. Gets preference in the naming as compared to the second low atomic weight heteroatom. Let us see an example. So this it is a heterocyclic system but contains two different heteroatoms. Now as we know, oxygen atomic weight is high as compared to nitrogen. So this compound is known as oxazole. So oxa is given as preference because of oxygen. It is given first preference, and azole is for nitrogen. Oxa is for oxygen and azo is for nitrogen, and it is a unsaturated 5-membered ring, so it contains ol as the suffix. So oxazole is its chemical name or IUPAC name. Next rule is how to number it. So numbering is given based on the heteroatom present in it. That is, the heteroatom gets numbering based on oxygen gets first, nitrogen gets second, and sulfur gets third. So if in a heterocycle, if more than one heteroatoms are present, then oxygen will get first numbering, nitrogen will get second, and sulfur will get third. But if it contains only one heteroatom, then the heteroatom will get as first and the remaining carbon will get the consequent numbers. Let us see an example. So what is this? This is furan, right? We had seen 5-membered ring with oxygen unsaturated, it is furan. So now if we try to give this numbering, always heteroatom gets first preference. So oxygen will get 1 and the remaining carbon atoms will get the other order of numbers, that is second, third, fourth and fifth. So always heteroatom present will get first number as compared to the other atoms present. Here other atoms is nothing but carbon atoms. If this case is if it contains two heteroatoms, let us take same example oxazole. So here as we seen, the preference is first given to oxygen, nitrogen and then sulfur. So in this system oxygen is present and nitrogen is present. So oxygen gets first. Now where should be the second position given? Either this carbon or this carbon. Here now in this case the second position is given to this carbon. Always remember the heteroatoms must get the least numbering. Here it was only one heteroatom, so it has got first preference. But in this case, if we go for the least numbering, this will be 3, 4 and 5. If we assume that if we give numbering on the opposite direction, that is if we give numbering in this direction 2, 3, 4 and 5. So here it is high number as compared to 3, 4 is high. So this system is not accepted, while this system is accepted. That is heteroatoms if present must contain as much as low possible number. Here it is high, here it is low. So second preference is given for this carbon and third is given for nitrogen. So this is regarding the heterocycles, classification of heterocycles and nomenclature of heterocycles. Thank you.